In this lesson, we'll talk about probability functions. We'll consider their basic properties, and we'll look at a couple of examples. So a probability function assigns a numerical value to each outcome in the sample space of a random experiment. These assignments must satisfy certain properties, the first of which is that each assigned value must be non-negative. So you can't assign a value of negative 0.5, negative 3. The second property is that all of the assigned values together must add up to 1. And the third property is that the probability of any event A has to equal the sum of the probabilities of the individual outcomes that comprise that event A. So let's take a look at an example. Consider this probability function that I've laid out here, where the sample space includes 1, 2, 3, 4, and 5, and the probability of each of those outcomes is given. So for instance, the probability of a 1 occurring is 0.44. Let's see whether these satisfy our properties. Let's first note that for property 1, each of the values indeed is non-negative. Those are all in fact positive, but we do allow probabilities of 0. The second property is also satisfied if we verify that 0.44 plus 0.27 plus 0.14 plus 0.08 plus 0.07 equals 1. The third property, this is more to illustrate the property than to verify it, but if we say our outcome will be odd, that's an event, and if we add up the probabilities of 1, 3, and 5, we get the probability of an odd occurring to be 0.44 plus 0.14 plus 0.07, which equals 0.65. Another event might be the outcome is greater than 2, in which case we would add the 3 probabilities for the outcomes greater than 2 to get 0.29. And that's the properties of a probability function. These 3 properties are all you need to build probability theory. These are the 3 axioms first really formalized by Kolmogorov back in the early 1900s. And these axioms have been used to build all sorts of theories since. And these axioms are pretty much accepted by everybody who studies probability, regardless of their philosophical opinions on whether we use a frequentist approach, a Bayesian approach, or a likelihood approach.